Hello everyone. I am Dr. PSV Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain the construction working of helium neon laser. So at the end of this lecture, the student will able to understand the construction of helium neon laser. What is the construction of helium neon laser? And what is the working of helium neon laser, means what is the output of this helium neon laser. Coming to the schematic representation, it is given here. In the schematic representation, say this is a long discharge tube. There is a long discharge tube and two electrodes are provided, one cathode and another one is anode. This is actually a glass chamber. The opposite ends are sealed with inclined glass window. This is one glass window. This is another glass window. It is sealed with two inclined glass windows. At the two ends, two mirrors are provided. This is 100% reflecting mirror and this is the partially reflecting mirror. Adjusting the distance between these two, we can get the optical resonator arrangement. Okay, we shall see the construction. And say once again, in the construction, this is a long discharge tube of 50 centimeters long, 50 centimeters long and 1 centimeter square cross sectional area. Two electrodes are provided. Through these two electrodes, we can supply the electrical discharge. Electrical discharge is possible. Two inclined glass windows are there. They are actually called Brewster window, or this is sealed with two inclined glass windows. Two mirrors are provided on either side. One is 100% reflecting mirror, second one is partially reflecting, which constitute the optical resonator or Fabry-Perot resonator arrangement. So in the construction, once again, the helium neon gas mixture is taken at the ratio 10:1. Means for every helium atoms, there is only one neon atom. And coming to glass tube, it is taken as 50 centimeters long, 1 centimeter square cross sectional area. Electrical discharge is possible. To provide that one, we are providing two electrodes, cathode and anode. And optical resonator arrangement is there. That means we are providing two mirrors on either side, 100% reflecting and partially reflecting mirror. And cooling arrangement is also provided. If at all some thermal energy is produced during the process of the emission of laser light or something, during this procedure, that should be cooled. For that one, cooling arrangement is also provided. Means water will be circulated around this one. So this is the construction of helium neon laser. Coming to the working principle. So in the working principle, we have to understand what is the pumping method, what is the pumping scheme, and how the optical resonator is working, and how the laser action is taking place, what is the output of the helium neon laser, so and so things we have to discuss in this one. Coming to the pumping method, that is electrical discharge method. There are actually different types of pumping methods, namely optical pumping, electrical discharge, direct conversion, this kind of things are there. Anyhow, here we are using the electrical discharge method. It is suitable for the helium neon gas laser. Actually, helium neon laser is the most powerful laser, gas laser. Actually, it is used for cutting and as well as welding of the metals in the industry. That much powerful it is. Anyhow, so this is coming to the working principle. We are using the electrical discharge method, and there is a 4-level pumping scheme involved in this process. I will tell you, actually this is the chamber, NA chamber. In this one, helium atoms, neon atoms are there. Whenever it is subjected to the electric field, what happens? Because of the electrical energy, ionization process takes place. Means the outermost orbit electrons will be removed. That means in the chamber, helium ions, neon ions, electrons also will be produced. Generally, the helium and neon positive ions, they travel towards the negative electrode, means negative electrode, and electrons will travel towards the positive electrode. Anyhow, during this process, what happens? The electrons will collide. Electrons will collide with helium ions. They will collide with neon ions also. But one thing, helium ions are very lighter bodies. That's why they will go to the higher energy states very easily. Neon ions are very massive bodies. That's why they cannot be promoted to the higher energy states. So later what happens? These helium, excited state helium ions will collide with neon, so that neon ions will go to the excited states, helium ions will come down. So the same thing I will explain here. Actually, basically helium ions and neon ions are there at the ground state. Due to the collisions with electrons, helium ions will go to the higher energy states. Neon ions are massive and also less in number. That's why what happens? Neon ions cannot be promoted easily to the excited state. We are utilizing the helium as a promoter in this one. Otherwise, directly sending the neon ions to the excited state is not possible. That's why helium ions will go to the higher energy states. Later what happens? These helium ions will collide with neon ions, so that the neon ions will go to the higher energy states. Okay. In this one, all these energy states are metastable states. Actually, if you observe this one, 1, 2, 3, 4, 5, 6. 6 energy levels are there, but it is not a 6 level pumping scheme. This comes under only the 4 level pumping scheme. Why it is 4 level pumping scheme? Here you observe these two energy levels are taken as higher energy band. It is taken as higher energy band. Some of the neon ions are going to somewhat higher level, some of them are going to somewhat lower energy level of the higher energy band. They are taken as a single energy band. Okay. Next, here this is taken as E1 state and this is taken as E2, and these two are taken as the ground state E1, and this is taken as E2 energy state. It is taken as E3 and this is taken as E4. I will explain why these two are taken as only one energy state. I will explain. Now this is one, E2, E2, E3, E4. Already the topmost two energy bands or energy levels are taken as one band. Some of them are going to lower band and some of them are going to higher. Anyhow, from this is E4, this is E3, E2, E1. Actually, different transitions may be possible. What are the transitions possible? So, the transitions possible may be E4 to E3, here E4 to E2, E4 to E1, something like that they will be possible. But actually, directly these ions cannot come to the ground state. If they come to the ground state even from E4 to E1, if they come to the ground state, what happens? They will release so much of energy, nearly 20 electron volts energy. If that much energy is released, say, automatically the glass chamber blasts. Anyhow, these helium ions will come to, some of the helium ions will come to the energy state E3. Some of them are coming to the energy state E2. Okay, and from E2 to ground state they will come. Okay, why these two are taken as the only ground state? Why? Because whenever they come to the energy state, this one, they come to the ground state by colliding with walls of the glass chamber. During this process, some thermal energy will be released. To cool the system, cooling arrangement is also provided. Water will be circulated around this one. So anyhow, from E4 to this state, some energy is released, that is 33,900 angstroms or 3.39 micrometers, 33,900 angstroms. It lies in the far infrared IR region. Similarly, from E4 to another thing is there, this is 6328 angstroms, that is in the visible red region. So this is in the visible red region. Okay, next another transition, this is 11,500 angstroms, 1.15 micrometers or 11,500 angstroms, that also lies in the far infrared region. Only the visible light is 6328 angstroms, it is in the red color light. Other light rays are invisible, they lie in the far infrared light. Actually, only red color light is seen. It is not 100% monochromatic light. Why? Because monochromatic means not only single color, single wavelength must be there. Here different wavelengths are there, but it is a continuous laser. This is a continuous laser. Why? Because the moment they come to the energy state, the higher band, they come to the ground state, the neon ions, again they are ready. What is the whole process? Continuously the electrons will collide with helium. Helium ions will go to the higher energy states. They transfer the energy to neon. Later, different transitions are possible. They come to the ground state. Again, they are ready for the entire process. So, this is a continuous laser. But still, there is one drawback. This is not 100% monochromatic. Different wavelengths are there. That's why this is not suitable in communication applications. Whereas we can use it in the industries for cutting purpose as well as welding purpose. Anyhow, once again, let us recap this one. Actually, we have discussed in this one construction of the helium neon laser and working of helium neon laser. In the construction point of view, just observe, it is basically a gas laser, most powerful gas laser. So, this is a long discharge tube of 50 centimeters long, 1 centimeter cross sectional area, and this glass chamber is filled with helium and neon at the ratio 10:1. For every 10 helium atoms, there is 1 neon. And 2 electrodes are provided for the electrical discharge. 2 mirrors are provided on either side. That means they produce the optical resonator. Means the photon generated during one direction travel, they will be reflected back in this direction, and finally means they will stimulate more and more number of ions, more photons will be generated, they will strike 100% reflecting mirror, again they will be reflected back. Light travels to and fro between the 2 mirrors, and finally after reaching proper amplification and proper energy and unidirectional light, it will come out of the partially reflecting mirror as a powerful beam with the wavelength 6328 visible red color light. Anyhow, 2 electrodes are provided in this gas mixture, helium and neon. So, when the electric field is switched on, what happens? Helium ions, neon ions, electrons will be produced. They travel in the opposite direction. Electrons will collide helium as well as neon. During the collisions, first what happens? Helium ions will go to the higher energy states. They will transfer their energy to neon ions. Therefore, neon ions will go to higher energy states and helium ions will come down. Now, coming to neon, there are so many energy states or energy levels. In this one, it belongs to a 4-level pumping scheme. What is the pumping method? We have to concentrate on some points. What is the pumping method? Electrical discharge method. What is the pumping scheme? 4-level pumping scheme it is. And is there any optical resonator arrangement? Yes, there is an optical resonator arrangement by 2 mirrors provided on either side of the glass chamber. And what is there any cooling arrangement? Definitely there is a cooling arrangement. It's water circulation will be provided so that if at all thermal energy is generated, so that it cools the system. So, this belongs to a 4-level pumping scheme. Different transitions are possible in this one. So, 33,900 angstroms, 6,328 angstroms, 11,500 angstroms, all these things except 6328 angstroms, remaining light is in the infrared, far infrared light, it is invisible. Only the visible light is the 6328 angstroms red color light. So, in that way, we get monochromatic, high energetic, unidirectional laser beam by using this helium neon laser. Thank you.